Bum 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 bum.
Tomatoes?
Hello, welcome to video 4, a Game Jam Breakdown for November 2016. I'm going to run through the game, discuss some concepts of my thought process when I created the game, as well as do an overview of the game. Then I'll break through some of the code and basically discuss at a higher level the game itself. All of the code will be available in any of the links below on GitHub. You're free to use it for anything you'd like. All of the stuff was made by myself. And everything should be fully commented as well for learning purposes. So let's jump right into this. This one's pretty simple. This was meant to just be a fun little puzzle game where I didn't really have to worry about control from the character. No real input. The character basically clicks on where they want to go and it moves them, which led to both some problems and then some solutions. I wanted to make this a little more fun, so basically when the player starts up, it just asks them their name. They can type in their name and hit enter. Gives them a long speech about what the game is and things like that, and you can click to start. Now there is some music in the game. The music was created using FL Studio, and it was just a simple track that I looped just to learn how to use it again. I went for a minimalist concept because I created everything in Engine. All of the meshes, all of the characters, all of the particles, all of the materials, everything was done in Engine, with the exception of the music because I do not know of a way to make music inside the game. This is pretty simple. Basically, if you hover over anything that you could move to, it'll flash. So like for example, I can move here, I can move here, and I can continue on to the exit. It'll glow when I get near the exit, like that. And when I click on it, we give a nice GPU particle shower because I decided to play with GPU particles and I love how many I could make. And then you go to the next level. Really simple and basic. You'll notice when you start, you have this little wispy guy who's meant to be your trail. So basically the theme was go with the flow, and my idea was basically you just go with the flow. You follow the guy to the end. Not the best use of concept, but I wanted to play with particles and this is my idea. Now the particle itself is following a path that's predetermined that can be editable in the editor, which I will show you when we get to that point, and made it really simple to just simply create the levels and allow the ability to define the wisp paths in design time, and I could make them where they don't even follow the proper path. I basically could design even more. I could even design multiple wisps, which I did later. Now here's where we run into one of our first issues. I added vertical items. Now my original movement method had it move over time. Rather than clicking on the point and warping to it, we were moving over time. So for example, 2 seconds, we would elevate up for a little bit, move over, and then drop down. Or we would elevate over and then drop down. However, during game testing and the final version that was released, it was determined that that started causing issues. And the issue was I would not properly calculate the code, and basically I hacked in movement code and it failed miserably. So that was removed from this final version, but the hacky code is still in there. If I had more time, I might implement some better movement, maybe some pathfinding for going up and down. But for now, all I'm doing is literally setting the player's new location, and it caused issues with certain legs. Now this item right here is a power-up. Basically, it extends how far you can go. Right now, you can see one tile on each. When I click on the power-up, we'll get a nice little particle effect, and then I'll be able to move 2 away. So you can see instead of moving 1 and 1, now I can move 2, 2. And this allows us to jump, teaches the player about power-ups, and the only way you can get to the end point is if you get the power-up. So it slowly introduces concepts such as power-ups, multiple movements, vertical movements, and things like that. Now you notice when this level started, it had 2 different wisps. One is technically a decoy, and the other one is the real one. One thing I learned as well, and that was the wrong button to hit. Okay, we'll just run through the things. I keep forgetting escape is close and play in editor. One thing I learned is during one of the playthroughs, one of the players actually fell out of the world. Because I don't have a kill Z volume, the player just kept falling. And because I thought I was... We'll go and start this back up. Because I thought I was smart enough to fix all the bugs, my pause menu actually didn't have a restart button. Because of that, the player technically got stuck and couldn't finish the game. So that's something to keep in mind. And a lesson to learn. Even if you think you've done everything properly, it might be smart to have the ability to restart just in case your player gets stuck, especially if it's in a puzzle game or something where you have some sort of checkpoints. So that's another lesson I learned after the fact I had already submitted it. You could get stuck, and then without a restart button, you're kind of screwed yourself. And as a developer, screwing the player and having them stuck and lose progress wasn't a very smart thing. So I got a little cocky, basically, and made a mistake, and I would not recommend doing that. Have ways of fixing things for your players. Now, you may notice down here, it says player name Matt. Randomly, it will change the player name. Now you can see player Victor. I thought that was a fun little thing to do. Basically, I have an array full of names, and it will randomly pick either the player's name or a different name every time you move. Just a nice little fun thing. You may have also noticed something else. I played with a little bit of animation on the UMG. If you look up here, every time we move, it's going to go ahead and move it over a little bit. Nothing fancy, but it gives a little bit of feedback, letting the player know, draw their attention up to the top. Hey, you're losing a turn every time you move. Basically trying to teach the player by playing rather than giving them instructions. Click here to move. Every time you move, you lose one turn. Make sure you follow the wisp or you will lose. You need to get to the end before your turns run out. You know, tutorials like that where you literally get stopped every couple seconds, I personally don't like. So I like to design my games where they are intuitive and it's not too much of an issue. Like, for example, our first level, let's we put in our name, for example, and we get in. The first level is intended to show them what to do. It's a simple path with a slow-moving wisp to the end. We technically only see three things. We have a purple platform we're on, which does nothing, a blue platform where if we move over, gives a glow effect, and then a yellow platform in the distance where we saw the wisp move to. We pretty much only have one thing giving us feedback. It's our blue item. And if we click on it, this gives us feedback, our turns go down, and we now can see two blue items. And as we move, our limitations are shown to us. We can now only move to the blue items. They're the only things that react. We are moving towards our yellow platform, and then once we get close enough to the yellow platform, it glows. Our turn counter goes down, and then it shows we win. So in one simple map without any real instructions, we showed what could happen. And then the wisp now moves faster, and then you basically start introducing longer paths, start introducing false paths. You'll notice that the player can no longer move. But we still give them plenty of time and plenty of moves. Even if they don't understand diagonal movement, they can still make it to the end without failing. We give them a couple easy levels of learning on their own. Then we introduce things such as fake paths, where if you don't make it all the way, you're going to die. Longer paths, things like that. We introduce one map where you have to move diagonally. If you watch the wisp, you'll notice the wisp itself will move diagonally. And when we get to that point, your only movement point is diagonal. So if you haven't figured it out by now, you'll learn you can move diagonally. For the power-up itself, the power-up is designed where it will be directly in the way. Our vertical ones are directly in the way. We don't have any way of getting around, and you'll notice that concept's introduced slowly. Our turns start going down as we're playing. We're running into less and less turns at this point in time. We give the player an incentive to go over there, because if they fail, let's say they go this way and they fail, they'll end up stuck. They can't get over there, and we basically end. Game will be over. We have another particle effect. We have to restart. Now they're inclined to go over to the power up, and when they pick it up, then you can now notice they can see too. And if they learn that they can now move as far as possible, they'll now be able to make it to the end. And it's intended to give a little bit of solid feedback on the gameplay. Then we introduce things such as multiple wisps. We introduce fake tiles. You'll notice they can't get to the tile. They can't activate the power up. They learn that maybe not every path is correct. And they'll find that they can't make it there. They have to restart. I try not to put too many paths in, so that way it's really just more of a learning game, a guessing game, and trying to make it to the destination. And kind of playing with the player a little bit. Nothing too hard. There's 10 levels total. I didn't want to make it too difficult. You'll notice we have the things going up and down with multiple paths this time. It's not intended to be a difficult game. It's intended just to have the player think, oh, you'll notice that we failed on that one. And it's going to continue on like that. And this is basically the game concept itself. Nothing too fancy. We wanted to make it where the player had enough turns, as you can see there, to make it. We start cutting down the extra turns. Then we start introducing things such as backtracking and forward tracking, duplicating maps. Once you get to the end, it's just a giant map that basically you have to find the right path, and it's a maze. So for example, if we went to level 10, we looked at level 10, this is level 10, and as you can see, it's a giant map with one path. Now here's one thing that will help if you're making a level, if you're designing something where it's dark and using materials that are like this. You have your different editor modes, lit, unlit, wireframe. Unlit works really well when you're working with materials like this. As you can see, working in this level like this is a little difficult, but unlit gives me the entire thing. So let's break through the blueprints and cover some important things. So here's our character. This character is just this. This was a temporary character I dropped in that I created in Engine, and I created it using the pen tool. And I just simply created a shape of a character, have it set to extrude to 20, export it to a static mesh, and then there's my character. Nothing fancy, but everything's intended to be done in Engine, and your pen tool is a really good tool to create quick and dirty things. So our character itself is just simply this static mesh. Now looking at the code for the character, if I pull up the character and not the controller, we're going to find some basic stuff. This is basically allowing our camera to move. Remember, we're not allowing our player to move. There's no keyboard input or mouse input or gamepad input allowing our character to move. It's just the mouse looking around and clicking on the appropriate things. So we just allow our cameras to pitch and roll. We allow the initial camera pitch to be set above the player. You'll notice when you first start playing, our camera is kind of at this angle. If you don't set an initial pitch, you're going to end up with your camera like behind the player, and it's a little disorienting. So a little user feature, just have the pitch up a little bit if you're using a third player controller, and you can do that just simply by adding pitch on the begin play. When the player is killed, I simply spawn the kill emitter and destroy the actor. So nothing fancy there. This is our disabled event for when we're destroyed. Basically, when I had the issue with the player falling through the world, I would destroy them, but then I'd start getting multiple events firing off, such as when the player was destroyed and things like that. I found the better solution was to simply give the option to restart to the player. That way if they do fall, rather than causing some weird game loop where I auto-kill the player, just let the player restart. Once they restart, it takes care of itself. We did have a time where the text render above the player was set to show their name. That became a little distracting, and I tried to create the most minimal UI that I could, so we went ahead and removed that, but I left the code in there. That is all the code basically for that. Our player system itself is pretty much a normal third-person view. We have a mesh, we have a particle for when we die, we have a spring arm with a camera attached to the appropriate place, and as you can see there was our text renderer, which is just currently set to disabled now and hidden game because we're not using it. Most of the things in the game I tried to use the least amount of casting as possible, so I implemented things as many interfaces. Our jam controller, all it does is handle the opening and closing of our interface. Our interface is our pause menu here, and we can use the keyboard to open and close it with the P button. You of course can't do that unless you have listening turned on in your user widgets and you're actually listening inside of here. This is basically just the code for my simple pause menu. So if you look at that video, you can see how to implement a simple pause menu. We have our jam character. All this is an interface for it, for killing the player. And then we have an interface for the controller, which simply toggles the pause menu. Like I said, I tried to use as many interfaces as possible because without having to cast, interfaces are great, and I love them. We have a couple things in our framework. We have our game mode. Now, this time I tried to basically put as much code in the game mode as possible, and I let the game mode handle things. Down here you'll see what I mentioned before. This is our crappy broken movement code, and I'm not joking, it's pretty crappy. It was doing things such as using timelines to move the player and things like that. But when the player moved up more than one block, or they had to move over more than one block and there was a vertical involved, basically it just screwed up. This code caused a few issues during testing, and I ended up removing it, and we just teleport the player. Now that one's pretty simple. Basically, we have an interface when we click on something, and we pass in what we clicked on. We basically set the actor transform to where we're going to. Then we go ahead and loop through all of our platforms that are visible currently. So everything you can see that has the blue highlight, and we tell them to not be visible anymore. Then we go ahead and we clear that out, and we go, okay, so what's around us now? And we use a simple, where is it at? Here we go. We use a simple sphere trace to determine what's around us. Sphere traces are great. If you use a very small distance between the start and the end, in this case just a z value of 0.01 distance, you basically get a circle around your start. And then you can, anything you hit around there goes into it, because we're doing a multi-trace. And I'm doing it for objects, so I only hit my platforms. So what this is going to do is this is going to output an array of platforms that are within a distance, which is my pulse radius. And the nice thing is this is a variable, so if I get the multiplier, I just increase my radius. We take all those platforms and we tell all those platforms simply to become visible, and then we check and see if we won or we lost. Won or lost is pretty simple. Basically, did we make it to the end, and do we still have turns left? And if so, flag it as a win or flag it as a loss. Really simple. But I check every time we move, because if you move to the end platform, that's when you want to check if you have successfully made it. Now the pulse visibility node is really simple here. Basically, this is going to find all those platforms. Like I said, we are setting to that are around us within a distance. We're going to set that to our visible platform array. We're going to loop through all of them, and we're going to tell them that they are now visible. And by being now visible, that means that their material is now set to on rather than the material set to off. That's how we're achieving the black look. Now, let's see. We have initialization stuff. This is pretty simple. Basically, load the settings for the level. To make things as dynamic as possible, I have a few helpers. We have our Wisp helper right here, and then we have our level helper right here. The level helper is really simple. It is literally a blueprint that, if we open it up, holds the number of turns for the level. And it has a public int that I can set. And that's it. Rather than have to hardcode things, I can simply have this item in the scene that the game mode will grab every time the scene loads up, and then ask it for how many turns there are. That's all its intended purpose is, and then I could just simply click on this item and change the number of turns. So like, for example, if I want it to be 35, I hit play, now we have 35 turns. I set it back to 40, now we have 40 turns. Makes it really easy to iterate when you're testing. When you're designing, if you're using the engine for level design and things like that, making things quick and easy to iterate through is important. Now our Wisp helper, let me go back to our first map and let me show you the Wisp helper so we can understand how it's intended to work. The first thing I started with before I created any of the levels, or my starting or my end maps, was I made a playground. Playgrounds are kind of important. They are helpful for testing things. This was just a blank scene where then I started adding in every single part. I created that, created my power-ups, created my starting, my ending, created my platforms, so I could test things. Now the Wisp is really nice. It's basically a blueprint that I can drop into the scene, and it has an array of platforms, and it has a lifetime. Now the platform paths are really simple. Let's say I had 5 of them for my Wisp. Let's go with 6. The platform path, if we open up the blueprint Wisp, and we look at our platform path, it's an array of type BP platform. That means it's only going to accept platform blueprints for its array values. Because of that, and the array is in the editor as public, we get access to not only a drop-down, which shows all of our platforms. So I could go platform 1, platform 2, platform 3. You could also, and this is really handy, use the eyedropper. I could go, okay, there's my first one, and there's my second one, there's my third one, and you can visually assign values like that. Now I have a little path. Now you might be thinking to yourself, well, what's this little path? Well, the Wisp is using the spline, and it's basically building the spline in the construction script based on the values in the array. Because these values in the array are public, anytime a value changes, it's going to go ahead and run the construction script. Now the construction script is pretty simple. We're basically going to clear out all of our current spline points on our spline component, loop through everything in our array, figure out where they're at in the world, add a z value of 25 so that way we can make sure they're on top of the platform rather than in the platform. Now the reason for that is when these items right here, these BP platforms, the root point or pivot point, the origin point basically is at the top right here, but I don't want the spline to be at the top. I want it to be up a little bit. So you can see it's 25 above where it's at. And then we basically, after we've taken that location and adjusted our Z, add a spline point to our spline. And then we tell it to update. And that's it. Basically, every single time we change a value inside of our Wisp helper, like for example, we add a new one, it's going to run the construction script. And then we click here, it's going to run the construction script. And it's going to simply keep repeating. And the nice thing is that allows me to simply create a Wisp in design time and visually see it and easily adjust it as needed. Wisp lifetime is pretty simple. It's just a float, and it basically drives our movement on the tick based on the duration, based on how long we want it to go, based on how long it is running inside of our tick. I let our movement code go inside of our tick because the Wisp has a lifetime. It's going to last for a couple seconds. It's a fire and basically forget blueprint. The level starts, we tell it to activate itself, the Wisp does its thing, and when the Wisp is done, it goes ahead and kills itself. So running it in the tick isn't really going to be a big deal. And since we don't have a predetermined path, that path is going to change for each Wisp. Using this and then setting the location based on the spline information allows us to set it. Now, if you haven't used splines before, it's really simple. There is a node called get location at time, and basically every spline, if we pull it up, has a time. This is how long the duration is for the spline from start to end. This spline lasts 0 to 1, or conveniently 0 to 100%. So by dividing the duration of the Wisp by the lifetime of the Wisp, I can go ahead and fill a 0 to 1 value into time and get a percentage back along my spline. So 0%, maybe 50%, maybe 75%, and then 100%. So it allowed me to move it over time based on how long my Wisp has been alive and I've told it to move. And then once we get to the end, I go ahead and just simply kill it. That's it. That is what our Wisp is. This is a simple activation event that actually spawns our emitter and tells our Wisp it can go ahead and move. And our Wisp is just a particle. And it's just a particle that I got bored with. I decided to play around with. And it's just this little sphere with another particle in the middle behind it where it's just emitting a crap ton of sprites that dither off slowly. I'm not a real good artist, but I thought they came out really well. So that was our Wisp. And that was our playground. And this was our level thing. Our power-ups are pretty simple. Power-up is just simply a text renderer with a public variable. Remember, make things simple in design time. I can take this item here and set its multiplier value. So it's 4 right now. And when I hit play, it's going to show times 4. Or if I need to be at 3 times, now it's going to be 8 times 3. So everything's designed. Everything can be designed in runtime by your designer rather than a programmer. And that one just simply, on begin play, it sets the text to whatever we set it to. When we hit it, all we're doing is talking to our game mode, and we're telling our game mode, hey, go ahead and set the multiplier value to whatever we just touched, and then destroy ourselves. That's it. Really simple. By keeping as many things as possible in the game mode, it lets me basically have things talk to it and have it handle everything. So basically, when the player does something, it tells the game mode it did something. When the player touches a the power-up tells the game mode it did something. When the player lands, it tells the game mode it did something, because when it spawns in, we don't start until we land. Whenever we move, again, we tell it, and then it pulses out, and everything talks to the game mode. In terms of other framework, we talked about the level setup. We have our blueprint interface for the game mode. Like I said, we click on a platform, we have an interface. We finish clicking. When we click on the finish thing, we have an interface. Pulsing around the player, there's an interface. Toggling music on and off, there's an interface. Miscellaneous, we have the materials for the wisp and the power-up. Now the power-up material is pretty simple. All I did was take a color and multiplied it by an emissive strength, so that way I have a glow. Then I took a generated offset bands. This is what lets me, let's do this. This gives me this really cool little effect where we have some bands being created. And I'm plugging in a time node into the offset, which basically gives me this weird pulsing effect. I'm not a material artist. I just started throwing in cool things, and I kind of like the effect. I think it came out pretty cool for a nice little effect built in. Our platforms are one of the main pieces of code. We actually have 4 of them. Almost all of them deriving from our basic platform. Now our basic platform is pretty simple. Everything's documented. But basically, on the begin play, hide ourselves and create our dynamic material instance. We use our dynamic material instance to pulse by basically setting the emissive strength. Handle being clicked on, again, if we click on it, we go ahead and tell our game mode we were clicked on, and then we set ourselves to not be clicked on again for another second. And then for toggling visibility, it's pretty simple. If we're cheating, we keep our visibility on. Cheating was an option I enabled. So for example, if you turn on the cheating, it basically shows all the platforms at all times. You still can't move farther than you're supposed to, but you can see where all the platform paths are. And that was intended just to be a way to make things easier. And all this code does is if we're not cheating, we go ahead and check to see if we need to toggle visibility. Now in terms of being able to click on stuff, if you notice, I can't click on these. These platforms are here, but I can't click on them. They're too far. They're not only too far away, what I did for that is simply toggled their response. I set their visibility to ignore or block. Now, visibly, these blocks are here. If we were to go ahead and pull up our menu and show them, these blocks are here visibly. Their material is set to basically black, so they're hidden, but visibly they are here, so they do respond to clicking. However, if they're outside of our range, I tell it to have the visibility channel, which is what my trace is firing off of, to ignore. So basically they act like they're hidden or not there. And that is actually kind of a cheat for our dummy platform. Our dummy platform is basically the same thing. It is a platform that is just like our parent, but it doesn't respond to clicking. It basically always has its visibility channel set to false, so therefore it's never going to respond to clicking, and it's just a dummy platform in the scene, and that's it. So that way it kind of technically is there, but it doesn't respond to clicking. Starting and finishing are pretty simple. Our starting, basically when our player lands on it, we fire off the initial pulse, and then we activate any wisps we have in the scene. For the platform when we finish, it's basically going to be the same thing, except it's going to fire off the finish event instead of the normal event. Everything else is pretty simple. We have an interface, we have some materials, and it's just for looks. This material is really cheap and generic, and basically I'm just taking a color and setting up generated bands, and the bands basically are on the edges. That's it, nothing fancy. I just want to make something simple that you couldn't see in the dark, yet you could easily notice. And our emissive strength is simply what we determine our visibility. So like an emissive of 0, it's going to give us no glow. Whereas if we had an emissive of something like 2, it'll give us a glowy effect. And that's how we end up getting our little pulse effect when the player mouses over. we basically toggle our emissive from the 1 value to the 3 value. That gives us a pulse or a glow. Or we toggle from 1 to 0 if we want it off and the player can't see it. And let's see, UI. UI is pretty simple. We use an interface for most of our UI things, setting our turns left and setting the player name. You don't have to use an interface. This is our, let's see, where's our main menu? Game UI, here we go. Our turns left and our player name. You could cast to it and you could talk to it. I prefer not to bind things. If you notice, this is not bound to any value and the player's name is not bound. I prefer to just set things. It's really simple. Basically, we have an event that handles setting the turns and we have an event that handles setting the name. So something can talk to this interface using the generic interface. Someone can talk to this user interface using the blueprint interface and tell it to either set the name or set the turns. And you'll notice on setting the name, basically I have a get random name. All this does is selects between true or false based on an index. The index is a random integer between 0 and 100, basically 100, 0 and 99. If we're greater than 90, we're going to go ahead and pull out a random name from my index, and this is just literally an array of names. Or if it's below 90, we're just going to put the player's name out. It's something a little bit fun, allows us to use the select node, allows us to give a little bit of humor to the game that they might not notice. And as you can see, it's really simple to implement. We're just basically going to pull out a random name from our array and plug it in here, plug in our player's name to here, and then do a random integer to determine which one comes out. Select nodes are really powerful for stuff like that. Let's see, rest of the interface. A game over screen is just a game over screen. It handles quitting, restarting, and then fading in our screen. The end screen is basically going to be the same. The UN is the same. Our start screen is really simple. Basically, we take our name from the player. We make sure when they hit enter, we assign our name to our game instance. So we save it between each map. We go ahead and tell it to welcome to the game. And then we play the intro sequence. And the intro sequence is just this right here. We basically have the name entry box and the intro box as two separate things on the same UI. They can click it to start. It fills in their name. I mean, it's really simple. The end screen is just meant to be a play on words, kind of like the old bad translated Japanese games. It even has a little bit of an end game sound cue I recorded because I always like to do a little bit of voiceovers. You know, you got there, make it a little bit more fun for the player. We have our different maps. Now our maps are kind of nice. I designed things to be as, again, modular as possible. Inside of our start map, inside of our level blueprint, we are basically grabbing whatever level name we are, and we are setting the level names variable into our instance. That means in here, inside of here, I get to I get to determine all of our maps. So it's modular. I don't have something, it's not fixed. Well, technically it's fixed, but all I have to do is edit this, and then this will tell the game instance the list of all of our names. And then that game instance, because it's persistent between maps, will keep track of it. So all I have to change is this one thing in here, and then everything's done in the proper order. Start map, tutorial map, and then each level will know in order which one it's supposed to do. Then I create the widget on the screen and show the mouse cursor. Nothing fancy. When we get to each level, and then we end up getting, where is our finish? Let's see, let's go to our finish platform. Oh no, not that. I meant to do the game mode. Because I try to keep everything in the game mode, this is what keeps track of starting and loading and moving to everything. When we check to see if we win or lose, in here, this determines what we're going to do. You win or you lose. In terms of the you win, we go back to our UI, we look at the you win, we pull up its stuff, and this one's pretty simple. We start the animation for you win, or we quit if they hit the quit button, or if they hit the next level button. It's pretty simple. We figure out inside of our game instance what our current level is, what our list of level names is, increment our index, so that way we're now on the next level, get the name, because again we're storing everything in our index, and then load it up. So everything is as open as possible and keeps things as separate as possible. And I only have to change inside of my startup map the level names once, and I don't have to keep them in multiple places. Besides that, that's pretty much going to wrap up everything. It was a fun little project. I enjoyed it. It didn't come out as well as I wanted. I spent a total of 12.5 hours. If you are curious about how this was created from start to scratch, during that week for the Game Jam, I actually streamed the entire time for the entire creation from start to finish. Everything I did is streamed live. It's about 12.5 hours over, I want to say, 4 videos. I'll put links in the description below as well, so you can check those out. If you have any questions or comments, feel free to leave them wherever you want. If you have any requests, feel free to leave them wherever you want. My takeaway from this Game Jam was, don't get cocky. Don't think you have accounted for every single bug. Like I said, I ran into 2 of them during the gameplay, and I watched 2 different people run into the same bug. My movement code was sloppy and hacky. I just said, oh, it works for now, and didn't fully test it. And because of that, we had an issue with people falling through the level. And because they fell through the level, and I didn't put in a restart button, they couldn't restart, and they basically couldn't finish. So, don't get cocky. Try to playtest as much as possible. Leave extra time for playtesting. I playtested a lot, but the problem is I got stuck in following the correct path, and I didn't try going to the wrong path, and that's where my problem came in. So because I was the developer, I got stuck in a rut with just trying to test. I didn't notice the errors, and sloppy code for my movement handling caused issues. Splines are a lot of fun to work with and super simple. I'm going to work with them more in the future. Defining this inside of the editor with the construction script and the eyedropper was a lot of fun and super simple to do. And I'd highly recommend people work with the eyedropper, public arrays, and the construction scripts for learning things. And that's it. That is going to wrap up the Game Jam Breakdown for November 2016. If you managed to stay through the video, I hope you enjoyed it and learned some things. And again, feel free to contact me with any questions or any help requests.